Hello everyone, this is Aurora with the Central Coast Astronomical Society. How are you guys doing tonight? I'm so excited for tonight's stargazing session. All right, Kent, are you there?
Yeah, can you hear me?
Yes, hello. Thank you for being with us tonight. Thank you for your persistence in calling in a couple of times.
Oh, you're welcome.
So Kent, before we get started, I have a question for you. I was wondering if you wanted to share with folks maybe who have never met you before, just real quick, just like maybe 1 minute, 2 tops, just kind of your background, like where'd you first get interested in astronomy? What's your favorite telescope, that kind of thing? And I'm going to show them a picture of you doing with your orange celestron.
Oh, okay. Actually, originally, I got a book called The Stars by H.A. Rey. It was to learn the constellations. I wanted to learn more about the sky. Once I got a bit better at it, I was using an old pair of binoculars that were my grandfather's, some 7x50 naval binoculars. And, basically in about 3 months, taught myself the constellations I could see from Visalia, California. And then later on got a little J.C. Penney's 60 millimeter refractor. It was good for looking at double stars and planets for the most part. And basically I stuck with that until I started working at Diablo and had the money to buy that big orange thing. And that opened up a whole brand new world for me.
Awesome, awesome. And so, what's your favorite telescope to observe if you were going to go out tonight?
Right now, it'd be Jupiter and Saturn.
Mm-hmm.
Just because they're such awesome planets and they're so close to each other. So those would be two I'd go after. I'd probably go after some of the stuff in the hook of Aquila the Eagle, in the fish hook at the bottom, like M11, those sorts of things. There's a bunch of planetary nebula in the Eagle there, so I'd probably be working my way through some of those.
Okay, great. So basically what we're going to be telling people tonight.
Pardon?
So basically the things we're going to be showing people tonight, correct?
Yeah. Basically, it's up high, it's overhead, so yeah, that's the stuff to go for. If you stay out later and later, other stuff will come up. But we're hitting the stuff that will be up once it gets dark right now. I'm pretty much overhead.
Okay, great. Okay, are you ready to go, Kent?
Yeah, let's go.
All right, let's do it. Okay, so for those of you that have just jumped on, this is Aurora with the Central Coast Astronomical Society. I'm on with Brian as well as Kent. Kent is going to be our astronomer taking us on a tour of the night sky tonight. If you have specific questions that you would like to ask, you can do it in the comment box. Brian will be answering those during while Kent is talking. And you can also, I'm going to make this go away, so please write this down if you need to. You can also put them through an email to questions@centralcoastastronomy.org, or you can text it to the number that you see there on the screen. Okay, so I'm going to take that off in about 10 seconds, and then we are going to get going. You ready? Okay, Kent, what is the first thing you would look at tonight?
Jupiter.
Tell us about
Jupiter would be the first one to look at tonight, and then slide over to Saturn. That would be the second one. They're both in the south. They're both very bright now. So those are the two big ones for planets.
Awesome. Okay, hang on just a second, Kent. Let me see if I can show people where this is. So if you look on, we're looking at Stellarium right now. This is what it would approximately look like if you were to go outside tonight. And do you see I've got these red marks here? If you can't read it, this one in the middle is south, and the one over here on the right is southwest, and then we have southeast. So I was wondering, what's an asterism?
An asterism is a grouping of stars. It's not a constellation. It's just a grouping of stars that people put a name to. The Big Dipper is an asterism. You know, it's not Ursa Major or the Big Bear. it's the Big Dipper, but it's just a grouping. It's not a constellation. And asterisms can be little small parts of constellations, or they can include multiple constellations. They're just a pattern that people recognize in the sky.
Nice. Okay, great. So what kind of asterism would you recommend people look at tonight?
Tonight, actually, there's several. I think there's about 4 of them, but the big one is what they call the Summer Triangle, and it's made of Vega, Altair, and Deneb. Those are all first magnitude stars.
Awesome. And so it's going to be a neck breaker, right? It's directly overhead.
Yeah, the younger people usually are a lot more flexible than the old geezers like myself. I've noticed as I've gotten older, it's harder to get at those high angles. But, for young people that are flexible, or if you're patient, everything moves to the west. So if you want to stay up late, it'll get to a better height above the ground. And those are almost overhead right now. Altair's a bit easier because it's in the south. And so that one, you won't be as high an angle, but Vega and Deneb, they're way up there.
Yeah. They are.
But, that's the good one to start with for tonight. I guess should I mention the legend behind those 3 stars?
Yes, please do, while I figure out how to get rid of my red box here. Hang on. Go ahead.
Yeah, there's a legend tied in with the 3 stars involving Hercules. Mm-hmm. And there must have been some different constellations at one time tied in with Vega, Deneb, and Altair. Those 3 represented these monstrous killer birds. They had iron wings, iron beaks, and iron talons, and they would eat people. And so Hercules' 6th labor out of the 12 was to go and, kill these birds that are eating people. And so it ties in with Hercules also, but that's, an old legend. Mm-hmm. We'll talk about some newer legends that's tied in with Deneb is tied in with Cygnus the Swan, and Altair's tied in with Aquila the Eagle, and Vega is tied in with a musical instrument, the Lyra or Lyre. So those are how it ties in.
Awesome. Okay, great. Tell me about, you were going to tell us about the Lyra. Do you want to start with that constellation?
Yeah, that's pretty much how the handout's roughly tied up like that. And Lyra would be a good one to start with. And there's the mythology behind Lyra as a musical instrument. Mm-hmm. And let me tell you that.
Yes, please do. And folks, know that I'm trying to get my pointer working again for you. So go ahead, Kent.
Yeah, there was this musician, Orpheus, who was the best in the world. He would charm animals, he would charm rocks, trees, humans, and gods. He was really good at it, and everyone loved to hear him play. And his wife got bit by a snake and died. So he played for Pluto and his wife, which are, he's a lord of the underworld, mm-hmm. to bring back his wife. His wife was called Eurydice or something like that. Mm-hmm. Hard to pronounce.
Yes.
But he was trying to bring back his wife. So he has to go to Hades and get her, but there's one condition, and that is when he's leaving Hades, he's not to look back. She's following behind him. And, once he leaves the underworld, then he can look back. Well, she was so quiet as he was leading her out, he didn't think she was there. So almost at the end, he turned and looked, and she was there. So he was doomed at that point. Aww. His wife went back to the underworld. He was despondent. He always played sad melodies. And even after he died, his lyre kept producing music. And so I guess to quiet the lyre, Zeus sent it up into the sky, which we know as the constellation of Lyra today. So that's I thought that there's a bunch of different legends, but I thought that was a cool one because I kind of remember it as a kid.
Yeah, that is a cool one.
And so that's the mythology behind Lyra.
Perfect.
I guess we should talk about the star, the bright star in there, which is Vega.
Yes.
Which is it's about 25 light years away. It's about 1.5 solar masses. It's what they call an A-class star. It's a white star. And it's only 385 million years old, so it's a fairly young star. It's also the 5th brightest star in the sky. And, our solar system is roughly 4.5 billion years old. So this is really a young solar system. They've actually seen a disk of dust around Vega. So Vega's kind of interesting that way. Plus, it's nice and bright.
It is. It's very bright. Do you want to talk about the double and a few things in this constellation, and then I'll back out and show people where to find it tonight?
Yeah, the double is neat. It's 2 binary pairs of stars that are separated. I've got, let's see, about roughly 200 arc seconds. So that's about 3.5 minutes, roughly, somewhere in that ballpark. And I remember I had a 90 millimeter refractor, just all lenses, and I modified it to get a 7 millimeter Nagler into it. And I could get both of the pairs, what they call the double. I could see the separation between each of the stars in it. So that was really cool with a 90 millimeter objective lens. And they're arranged, they're actually epsilon 1 and epsilon 2. Epsilon 1 is the northern one, and epsilon 2 is the southern pair. Epsilon 1 is roughly a magnitude 5 and a magnitude 6 star with a separation of 2.8 arc seconds, so fairly close. And then the southern pair, epsilon 2, is roughly a magnitude 5.1 and 5.4 with a separation of 2.6 arc seconds. So they've got roughly about the same separation.
That's amazing. So what looks like to your naked eye, just to kind of recap what Kent was saying, in this little teeny tiny constellation here, I'll connect the dots for you. So if we're looking here, so this is the bright star Vega, and I'll show you where to find that in just a second. And then if you kind of look just right next to it, there's 2 stars that you'll see don't look quite like a pinpoint. It'll look more like an oval with binoculars. And if you put a telescope on it, each of those 2 will resolve into 2.
Yeah, that's awesome. The cool thing.
Yes.
That's why they call it the double.
Awesome. Okay, do you want to talk about Delta 2?
Okay, Delta 2 Lyra. It's a good binocular one, I think, and if you got good eyesight, probably better eyesight than I got, you can at least see the separation. It's easy to see in binoculars, but if you got really good eyes, you might be able to see it. Because I think about the limit for super good eyesight is about 60 seconds of arc. And so that's just kind of a good practice type star.
Yes. And when you look at it tonight, it'll kind of look like this. So how do we find this? You don't have all these little sticks connecting all these dots, right? So how do we find this? Okay, so Kent, let me interrupt you for a second here. So if we are looking, it's pretty much overhead. So I can go north and look up, or I can swing this around. Sorry, I don't mean to make you sick. And I can go south and look up, and I'm going to see the 3 really bright stars here. Let me turn off the little dots. Okay, so I'm going to be looking for 3 really bright stars. And so Deneb, Vega, and Altair. We're actually going to hit all three tonight. They're each part, as Kent mentioned, part of a different constellation. You see there's an eagle here, this is the harp, and this is a swan. So these bright stars are in different constellations, but they're an asterism because we think of them together. So in Vega, so you're just going to go out tonight and look up, and you'll see two stars that are going to be closer together, and then Altair is going to be the one over here by itself. And Vega, this is the one we're looking at, and if you see Vega and you drop down to inside the triangle, you're going to see a parallelogram of stars. Do you see that? Right there, that parallelogram right there. Here, I'll connect the dots so you can see it better. Do you see that parallelogram? That's what we're looking for. And this is the little naked eye one he was just talking about, and the double-double is right here. So just by knowing where Vega is, you can kind of zoom around with your binoculars and kind of look around and see if you can find things. All right, Kent, what else do you want to tell us about Lyra?
You know, it's really useful if you have like that, the stars by H.A. Ray, because it shows Vega, it shows the pattern that you're looking for. So I actually had an old flashlight I put my mom's nail polish on to make it a red light. Put it on really thick, and that's the way I could recognize the pattern with the binoculars. And so that's, you know, a good way of getting it, or the chart that you give out. You know, as long as you've got that, you can work out the pattern with your binoculars. And let's see, the next thing to talk about is beta. Actually, I'd like to talk about beta Lyra, and also gamma Lyra. But beta's the weird one. Beta's got two massive stars right next to each other, and as one evolves into a giant, it drops mass onto the other one. They're actually distorting each other. They're so close in, and they're really massive. So they're actually changing their evolution by swapping mass around. And when one becomes a giant, then it spills out mass into the other one. Since the other one's getting more mass, it'll probably become a giant. And so beta Lyra is kind of an interesting binary system. You can't see any of that other than just realizing that star has neat properties. And then gamma, the reason I brought up gamma is it's the other bright one. It would be to the left and down a little bit. And the two make it real easy to find the ring nebula. And that's the reason I wanted to bring up gamma and beta is you can actually see gamma and beta naked eye. And if you put your telescope right between them and wiggle it around a little bit, you'll see a little donut hanging in the sky there. And I've seen it really nice and clear in my 8-inch, but even my finder scope, my 8x50 finder scope, if I use an O3 filter through that, I can actually make it pop in. It only looks like a star. You actually have to have, you know, a telescope to get it large enough so you can see a diameter. But yeah, the M57 is like the archetype planetary nebula. It's known as the ring nebula. I think maybe John Herschel may have given it that name way back in the 1800s. But it's a real interesting planetary nebula. When I show it to people, I call it Homer's donut because it really does look like a donut through the 20-inch.
It totally does. It totally looks like a donut. Did you want to tell people about eclipsing binaries, like for 30 seconds?
Oh, that's right. That is like eclipsing. When they're between our line of sight, they're lined up perfectly. One will move in front of the other, and if it's dimmer, it actually blocks the light from the brighter component, and the brightness drops. Then when it swings out, you've got the combined two of them together, and then one slides behind the other one, and it causes another drop in the brightness. So that's, yeah, I forgot to mention that. It's an eclipsing binary system. It just happens to be lined up so, you know, we can actually see the variability, I believe, with beta Lyra. It actually gets dimmer and brighter over time. Since these guys are swapping around there.
Oh, yes. Yeah. The image I showed is not the one we're talking about. That was Venus transiting the sun. And that was real data, not just something that was not an animation. That was real. So when Venus crosses the path of the sun's dims just a teeny little bit. And you can see that in the little light curve wiggle that I showed you. Okay, great.
Oh, got some more information on M57 or the Ring Nebula.
Oh, yeah.
So
go ahead.
it's one of the Messier objects. It's also roughly about 2,300 light years away. Don't hold me to that because planetary nebula are really, really bad for distances in the professional journal. They're scattered around, but it's out there a ways. Its visual magnitude is about 8.8, so it's not, it's actually fairly bright for a planetary nebula.
It is.
But I've noticed in my 8-inch, when you look at it under good conditions, you don't have to be real high power, just enough so you can see the ring pretty nice. There's actually like a faint haze or like a gauze across the inside of the ring, and you can see that in like an 8-inch. It isn't that difficult, but it's something that I don't think I've ever seen that in other planetaries like that. And so it's kind of a neat aspect of the Ring Nebula.
Now, Planetary Nebula, there's no planets involved. Do you want to just touch on that real quick before we move to Cygnus?
Right. It turns out that the reason William Herschel called them planetary nebula is the geometry. They look like a disk, and planets look like a disk. And so that's why William Herschel called it a planetary nebula. He really didn't know what they were. Later on, he suspected that it was made out of like a gas or a fluid, but that was later on in life. But they have nothing to do with planets. They're just, stars that have essentially burned up all the hydrogen in the core, and they reach the point where they're making a white dwarf in the center, and there's no more energy. They essentially blow off outer layers, and that white dwarf in the center, the pre-white dwarf, gets extremely hot, gives off hard ultraviolet, and causes the outer layers that have been thrown off to glow. So you get all sorts of geometries. It may be due to a hot Jupiter. It might be due to another, like a binary star system. They still don't know why the shapes are the way that they are. You'd expect that a spherical star would generate a nice sphere, but it always doesn't work that way. The ring's pretty good. At least it made a ring. Yes. But there's so many weird-shaped planetary nebula.
It is. This one's like looking down a toilet paper tube. It's like a barrel that's expanding.
That's one of the models. It actually kind of tapers down, and then also it spreads out as you get away from it. And long-term exposures actually show a fainter envelope around the Ring Nebula that you got to do photography. You can't see it naked eye. But it's been shedding material for a long time to get in that state.
All right. You ready to go say hi to Cygnus now?
Oh, pardon?
Should we go off to Cygnus the Swan?
Yeah, Cygnus. Yeah, okay. I'm sorry.
Yeah, no problem.
Yeah, got Cygnus here.
Okay. So how do we find Cygnus? Let me show people where to find it. Let me turn off all these little fancy labels. I wish these labels were out there at night, don't you? When we go out there, but they're not. So
Cygnus
let me even...
Cygnus is pretty easy to find naked eye just because of the asterism that's inside of Cygnus, which is what we call the Northern Cross. And you've got Deneb, which is actually the tail of the swan. And then you've got Gamma, which is the center of the swan or the center of the cross. Then it's got this long neck that goes to a really neat double star called Alberio.
There we go. And Alberio is his head.
Yeah, it's the head of the swan. And in fact, the wings extend out a little extra on each side from the actual cross figure. The cross is interesting because the Northern Cross figure is you can actually see it there as you got the cross arms and the upright, where Deneb's at the head of the upright. But on December 25th, it stands around 9 o'clock on the western horizon. So the cross there is kind of an interesting asterism, or Northern Cross is an asterism, because they've also got the Southern Cross down in Australia.
Yes.
And so, that's really neat.
Yeah.
Well, should we talk about Deneb, because it's kind of a neat star?
Yes. Tell us all about Deneb. What's so cool about this star?
Yeah, Deneb is an awesome star. It's a long, long ways away. I think, what did they say for distance? If I remember right, it was, about 6,000 light years? Something.
Okay.
It's way out there. And the interesting thing about it is that it's a supergiant. It's a white supergiant. It's, here I found the figures. I can never keep figures in my. It's 2,600 light years away. They figure the latest figures.
Awesome.
But it's a massively large white supergiant. It may be the brightest one for a Class A supergiant. It's about the size of the orbit of the Earth around the Sun. So that's about 200 times the diameter of our Sun.
Wow.
And so it's really big. It's also, brightness-wise, it's about 10,000 times brighter than our Sun. If you could move it in as close as Vega, it would be as bright as a big crescent moon.
Whoa. So if Deneb was where Vega is, it would be huge.
Yeah, it would be a monstrously bright star. But instead it's so far away. I mean, it's roughly 100 times further away than Vega. And so, that's a long ways out there because of the inverse square law for light.
Yeah.
And so, it's really a unusually bright supergiant. And the thing is, you really don't see it by looking at it. It's actually, visually, it's dimmer than Vega or Altair.
Got it.
But then it's a long, long ways away.
It is. So what is the thing that everybody looks at when they go to Cygnus?
Actually, they look at the Northern Cross, but the real crowd pleaser, once you get looking at specifics, it'd be Alberio. It's like one of the prettiest double stars in terms of color. You've got icy yellow and blue. And if you use low power, wide field eyepiece, you'll see the color really nicely. You don't want to go high power. Just have a nice wide field. They're separated by, about 35 arc seconds. So they've got a good separation. And they look really pretty. I mean, it's one of the most, it's called like the prettiest colorful double in the sky is Alberio.
Mm-hmm. Awesome. Okay, so let's practice, everyone, before we move on to our next constellation here. Let's practice finding it. Okay, ready? I'm going to make all the star names. Actually, my star names are locked. I have not been able to get rid of them, so we'll just leave them there. But let's see if you can actually find them. Okay, we're walking outside. You and me, we're walking outside. All right, we're looking north. Okay, so where are we going to find here, I'll mess up the sky. Whee! Okay, so we're gonna go north, and then we're just going to look straight overhead. And boy, it really helps when the star names are still there, huh? I've been trying to get them unlocked, and my keyboard is stuck, I think. And so you'll see these 3 stars that are going to form a triangle. Now, where is Lyra? Do you remember? Okay, so you go just inside. You go to the big, so Altair is going to be over here. We haven't talked about him yet. He's associated with the eagle. So Deneb is going to be Deneb is actually Latin for duck butt. So this is the butt star of Cygnus the Swan.
Yeah, it's a tail of the swan.
Yep, it sure is. And then here are the wings. You see that? And then if we go here, here's the head. It's pretty much in the middle of that triangle, and that's Alberio with the 2 different colored stars.
And you know,
Lyra,
to tell you how important Alberio is,
tell us.
they gave it the beta. You've got alpha for Deneb. It's really not beta in brightness. There's, you know, gamma is brighter than beta, but because it's such an important, colorful double star, they gave it beta, which is kind of interesting.
That's awesome. And Lyra, did you find it? Did you find the parallelogram? Yep, it's really close to Vega. It's right here. And where's the double-double? Can you see it? So here's the parallelogram. The ring nebula is right in here. And here's your double-double. See, look at all these things you know where they are now. And the double-double is just, it's similar to the one Alcor and Mizar in the Big Dipper, where if you zoom in on it with binoculars and telescopes, you'll split it into more and more stars, even though they all combine into look like one to your naked eye. Okay, Kent, what should we talk about now?
Oh, one other thing about Alberio is they're uncertain whether it's a binary or a, you know, just a line of sight double. The separation is so large, they might as well not be a binary, because they're saying it takes way beyond 10,000 years if they are a true binary. We don't know. There's, you know, questions on both sides. Oh, I see a beautiful picture of Alberio.
Yes, that was actually one. I don't actually have the astrophotographer name. Usually I do. Okay, great. So tell me about what else is in Cygnus that we'd want to look at, like a nebula or something?
Yeah, there's a supernova remnant, which is called the Veil Nebula. Mm-hmm. And, you know, the pictures of it are pretty awesome. It's quite large. I think it's roughly about six full moons across from one side to the other. There's an eastern side and a western side. The western side they call the Filamentary Nebula, and it goes right by a naked eye star called Cygnus 52. And, you know, it's really nice to have a bright star next to the deep sky object that you're looking for.
Yes.
And in my 8-inch without filters, I can see the wisp going right by Cygnus 52. And it's also given an NGC number. What was it? 69.
Oh, I actually wrote that down. Wait, let me grab my other slide. You beat me to it. 6960. That is what you told me.
Right, the filamentary side of it.
Were you thinking the other side? Oh, were you thinking the other side?
The other side is the eastern side of it is called the Network Nebula. And that truly looks awesome in my 20-inch when you put like a 2-inch 03 filter in my big eyepiece. You get filaments going everywhere. Basically, I have people grab the scope and move it to follow the detail. I mean, there's, you know, it looks like an egg crate pattern to me. There's so much detail in the Network Nebula part. Also, if you have dark skies and good eyes, you can actually see the Network Nebula in a pair of binoculars, since it's all by itself out there kind of hanging in the darkness.
Wow.
My eyes aren't that good, but there are people that have seen it with a pair of like 750 binoculars. Yeah, nice. But it looks totally awesome. You can see by the pictures there's a lot more stuff in there. There's kind of like a wedge-shaped object kind of in the middle that extends downward. I think that's called Pickering's wedge. There's just a lot of stuff there. And I've had kind of fun with my 20-inch to try and follow the different pieces of it, because it's really a big object. And supernova remnants are relatively rare. And so, you know, there's like one in the Messier listing, which is M1 or the Crab Nebula.
Yeah. That's awesome. So where do we find this thing?
It's actually, if you know how to find 52 Cygnus, that's the easiest way. Okay. It's off one of the wings, the first part of the wing of Cygnus there. And so I see the graphics will kind of show you where to look. It'd be on the eastern side of the Northern Cross or Cygnus there, about the middle of the wing, and then 52 Cygnus is just over from that. So the easiest thing is to find 52 and start there because it's a good indicator. And then if you want to, you can just cruise on out into the darkness looking for the Network Nebula. If you go at the right angle and far enough, you'll stumble across it.
Awesome. So here it is with all the things taken off again. Here's our summer triangle that's straight overhead. So this is great if you put down a sleeping bag and then you have your binoculars and you're like laying on pillows and cushions and sleeping on soft stuff, right? Because you can look straight overhead and not like kink your neck. So you're looking straight overhead. You're going to see this right here. You're going to see the 3 stars. And so again, there's Lyra with Vega. So Deneb, you're going to find him. Do you see that? Now, where are the wings? Do you see the wings? There they are. Great. Now, where would we start to look? If we suddenly forgot, we know it's this wing. So I would start looking at some bright stars around here and see if I can maybe pick out the right one. And look at that. You will find it. Now, here's a picture taken last week by an astronomer from our club of this exact thing that I'm showing you here. So here, he actually took a picture of this from his little observatory he has set up. And I'm trying to find it. Where is it? It is right here. Here it is. Okay. So this is a picture that he took from, I think it's Los Osos, or it could be Morro Bay. I don't remember. So this was an image taken by Peter. And so this is the one that was taken from really dark skies, and this is from our own little Central Coast area. Isn't that cool?
And that's going right by 52 Cygnus there. It's amazing how many filaments there are in that nebula.
Tell us more. What else should we be looking at?
There's actually a little cluster of stars that kind of are like the Pleiades. You know, it looks like a little dipper, but it's kind of short on stars. And it's called Messier 29. It's kind of towards the central body or over from Gamma, if I remember correctly. And it's just a little open cluster that, you know, if you look at it closely enough, you'll see this kind of truncated Pleiades or truncated little dipper type figure in it.
Nice.
There you go.
Okay, now to find that would be, there's Deneb, there's our little duck butt, and there is the body of the swan and the wings of the swan, and so you're really close to that intersection there. If I turn on the lights, maybe that'll be, the lines, it'll probably be a little easier. You can find it right there.
Yeah, it's not far from the center star there, which, you know, I call Gamma. It's what, Satyr or something like that.
Yeah.
You know, there's actually a lot of telescopically interesting objects around that area. You know, it's loaded with, it's right, you know, along the center line of the Milky Way, so it's loaded with dark nebulas, and there's actually a Wolf-Rayet star that makes a big crescent, which we haven't even discussed, or, you know, but it's an interesting object near that Gamma star there.
Nice.
Right in the center of the Northern Cross.
Perfect. Now, was there, I think we covered most of Cygnus that we wanted to cover. Somebody had asked about the black hole, and yes, the first black hole that was ever discovered back in the 70s was from Cygnus.
Oh, I know something about that.
Tell us.
You know, I think it was called Cygnus X1.
Yes.
And there was a famous astrophotographer by the name of David Malin down in Australia. And what he did, he took a bunch of photos around you know, they had rough coordinates because it's really hard to, you know, bring in something like that. And he was looking for, it's actually in a binary system. You've got the black hole, and then you got the star in orbit around the black hole. And when the star whips around the black holes coming towards you, the light is blue shifted. When it goes in front of the black hole and leaves, it's redshifted. So he took a bunch of photos looking for a star that changed color. You know, as it's shifting around, it would be red one time and blue the other. And I didn't know this until a few years ago, the story behind this. But that's how they found, you can't see the black hole, but you could see its effect on its companion there, you know, looking red and then looking blue. And he was really famous for doing color astrophotography with big monster telescopes.
There it is. I just found him as you were talking. Here we go. Yes,
And
that's
so
exactly what he
that's
did.
a story I remember.
And that's him.
I
You
thought it
can
was
actually
fascinating that he just looked for a star changing color.
So you can
And so
read
that's
more about him as well. Professor Paul Murden.
Oh no, it wasn't Paul Murden. It was
wasn't?
actually
His name is here with it.
David Malin. David Malin might have been working under him. You know how the
yes,
graduate
I do.
student is listed as et al. In the paper. So David Malin might have ended up as an et al. in the graduate paper about Cygnus X1, but he's done well by the work that he's done over the years.
Oh, we all know about that. Okay, so working for other people, not quite getting your name on the first listed. Okay, great. All right, let's see. The question, let's save some of those questions that we've got for more of the end. I don't see anything about Cygnus specifically. Okay, great. Do you want to go on to the little fox?
Yeah, let's go to Vulpecula since it's kind of shoved up against Cygnus there.
Okay.
And it's got a couple interesting things to cover that are binocular objects.
Okay. So we're talking about this one here. So you remember how to find Cygnus. Oh, wait, let me turn off the things. So we're looking at Cygnus the Swan here, and here's Alberio. And the one we're going to talk about now, Vulpecula, the little fox, is right off of Alberio. Okay, go ahead, Kent.
Yeah, it's more of a modern constellation, but the cool thing is it's got Messier 27, which is the Dumbbell Nebula. It's one of the 4 Messier planetary nebula, and it's very visible in binoculars. Looks like a little cloud. In my 20-inch, you can actually see the dumbbell shape, and you have blowouts on the other sides or the darker sides. You can actually see faint blowouts. So the dumbbells probably, it's the very first planetary nebula ever discovered. Charles Messier didn't know it was a planetary nebula at the time, but, you know, it was the first one date-wise. You've got 1764. Actually, it's found on July 12th of 1764.
Wow.
The only reason I know the date is because that's my birthday. So,
oh!
yeah.
Not the 1700 part, though, right?
Yeah, not the 1700, but, you know, the actual date, he found it on July 12th, 1764.
That's amazing. Just the fact that you knew that, you didn't even have to say why you knew that. I mean, I think half the people are picking their jaw up off the floor right now.
You know I'm a planetary nebula nut, so...
I know you are. That is your thing. You've totally got it. Okay, so how do we find this thing?
You know, it's relatively bright at magnitude 6.4 or so, and it's relatively large at 8 arc minutes. So it's a big object. You know, let's see. You've got 30 arc minutes for a full moon, so it's 8/16. Yeah, it's roughly a quarter of a full moon, so that's good sized. I don't know, they might be fudging a little bit there, but it's definitely visible in binoculars. It's a really nice planetary nebula. It's roughly about, I've got number of 1,150 light years away. Again, never hold someone to planetary nebula distances because they run all over the place.
They do. Okay, here. So I'm going to make all the lines disappear. You guys see if you can put your finger on that one. Here, disappear, and then we've got one more thing. We're probably going to be together for probably another 15-ish minutes. We got one more constellation to do. So here we go. Here's the summer triangle. Yeah, go ahead, Kent.
Oh, I was thinking another quick way to find the dumbbell.
Yes.
Remember how we were talking about that, where you go halfway, you know, distance-wise, if you go halfway between Alberio and Gamma, and you rotate that down to right angle along the, you know, for the axis of the cross, that'll bring you to the dumbbell. And so that's one way of finding it, is to actually use the, you know, as a distance and a right angle from Alberio, kind of down to the east there.
Yes, so he's saying if you go along the body here, just from Deneb along the body of Cygnus the Swan, and then you make a 90-degree turn and go about half the distance from these two bright stars in the body, and then you'll hit it right in this area. See?
But it should show up in binoculars, so if you sit back and just cruise, you'll find it.
Yep, and that's the fun part too, just kind of exploring and seeing, and sure enough, here it is. Awesome.
And then we've got the coat hanger.
Oh, we forgot about the coat hanger. Okay, let's see if people can see this. Yeah, we got to talk about the coat hanger
because it's really an asterism.
Tell me.
It's another asterism. It's also referred to as Brokel's cluster, which, you know, I don't know how they came. I guess he found it, and so I think he was a scientist in the 1700s or something like that, and. People thought they might have been an open cluster, but the stars are going in all different directions. So, you know, it is not an open cluster. It's just kind of a neat alignment of stars that looks like a coat hanger.
It does look like a coat hanger. So do you see it? It's kind of upside down. I don't know if I can't rotate this that quickly, but here are the stars that are all in a line, and then here's the hook. So there's our coat hanger right there. It's
an easy binocular object, and it's right in the border of Vulpecula there.
And just for comparison, here's the little fox, and here is the dumbbell we just talked about. And so it's between these two constellations. And so you go over here, and you'll see the coat hanger.
And do you want to talk about Aquila the Eagle next?
Yes, let's talk about Aquila. I didn't know much about this one until you told me about it.
Yeah, Aquila's interesting.
Yeah, it really
you know,
is.
One of the legends that Zeus had his gopher or fetch eagle. It would go and pick up humans and bring them up to serve for him, or it would carry his lightning bolts for him. He really liked his eagle, and he called it the Prince of Birds. And so, of course, Zeus would put it up in the heavens because it was his favorite fetch eagle or whatever. But yeah, that's the there's actually a bunch of different legends, but I kind of like the fetch eagle one, so that's the one I'm sticking with for now.
Yep. And so the bright star in this one is which star?
That is Altair, which is an unusual star.
Tell us.
Altair is only, let's see, it's about 17 light years away in distance. It's about I got 1.8 times the mass of the sun. The interesting thing about Altair is it is spinning extremely fast. In fact, if you doubled the speed of it, it would tear itself apart. As it is, it's turning on its axis every 9 hours. And it's about twice the equatorial diameter of our sun. Our sun takes 25 days roughly to spin once on its axis. So, Altair's really booking along. And it's spinning so fast that the equators have expanded out and the poles have shrunk down. So it's twice the diameter of our sun in the equator, but yeah, kind of like an egg. I mean, the thing is really kind of stretched out at the equator because it's spinning so fast.
Wow.
And so that's kind of like the claim to fame. It's 11 times brighter than our sun, and it's just the shape of it. If you were in a spaceship looking at it, you'd see this doesn't look right. It's not a nice sphere. And so it's, it's really hauling. Why
amazing.
it's spinning so fast, I have no idea.
Now, most of the things we've talked about, we can see naked eye or with binoculars, with the exception of the ring. Now,
also,
yeah.
Alberio is called the Eagle Star by the Babylonians and the Sumerians.
Oh, okay.
And so that's another little tidbit that I managed to dig out of the books.
Now, so there's something in the handout that I printed, but it's more of a telescope object. This was kind of like a little bonus for those of you who may have never seen the Snowball Nebula. You'll find that information down here, and you can actually find it in one of Altair's wings. But that's not going to be a binocular object. Do you want to talk about V Aquila?
Yeah, let's talk about the fishhook at the bottom of Aquila first.
Yes.
Because that ties in with V Aquila, but you can see there's like a little hook at the bottom of Aquila the Eagle there. It's actually part of the hook is going into a small constellation called Scutum there. But there is an interesting star. It's like the second brightest one. You've got the bright one at the end of the tail, and then you go down a little bit further, and there's a second brightest. I think it's called 12 Aquila. And there's three little stars that are peeling off above it, and then they point towards a red star. You can actually see the color. I've seen it in my 8x50 finder scope. It's called V Aquila, and it has a real colorful tint, especially if it's at a minimum. It's a variable star, so it gets a little brighter, a little bit dimmer. When it's in the dimmer phase, it's actually what they call carbon star. The actual physics of the star is making a lot of carbon, and it gets drugged up into the atmosphere. And the thing about carbon is it scatters blue light really well. And so you're losing all the blue light, you're just getting the red light come through.
Awesome. And so again,
does that kind of make sense there?
Yeah, right at the tail here, we're looking at the tail itself, and then we're going down one, and then there's this little curve of stars.
Yeah, there's three little stars that kind of curve off, and then they kind of point towards,
if
you
extended
it,
here. So that's
would
one
be
you can look at.
V Aquila, which is, it's just, it's real easy to find because that fish hook is easy to find.
Yeah.
And then you just kind of go off that little arc, and there's V Aquila. So it's always nice when they're easy to find like that.
Yeah, it is nice. Now tell us, there's M11?
Yeah, M11 is in kind of just below the fish hook, and it's actually in, a Scutum, but it's such a neat object, and because it's near the fish hook, I figured we'd throw it in. M11 is a very bright and condensed open cluster, and they called it the wild duck cluster. I'm not sure, but if you had a really, really bad telescope and maybe bad eyes, you could call it like, a V shape with, ducks flying south or something or north. But to me, one of the club members called it the Borg cube. And it does look kind of like a cubical form. There's actually one kind of yellow star kind of towards the corner, So we've started calling it the Borg cube at the star parties. And it's fairly bright. It's magnitude 6.3. In my 20-inch and with the low power 32 millimeter eyepiece, we're running about 79 power. It does look like a Borg cube.
It does.
And but the wild duck cluster, that has like the priority. It's like a really old nickname, so you don't get rid of really old nicknames. They stick around.
It's like the ones you get in school you can't get rid of. Okay, so real quick, I'm going to show you relative to the summer triangle here. Deneb, Vega, and Altair. Remember where the harp is? It's up here. Lyra is the parallelogram, and we have the double-double. That's in here. The ring is over here. Deneb, that's duck, but for the star for Cygnus the Swan. Alberio is its head, which is on its way through the two other bright stars here. that has the double, the red, and the red. It's kind of an orange and blue color. The wings were here. There was something interesting right by the cross. There's also something interesting right off this wing. And then over here, we see Altair. And Altair, let me put it a little bit higher. Okay, and then here's the shape of it. You got it? I'm going to turn it off. Okay, here's the shape. Okay, so we're going to go this way for the body. And the wings kind of come out here. The snowball is in one of these. I forget which one of these wings. And we didn't actually show it tonight. And then this is the hook at the bottom with the carbon star down here. And then, so just look at the tail end of the eagle, and you'll be able to see the wild duck cluster we were talking about and that reddish variable that was in there. How's that for star hopping?
Yeah.
How'd I do?
Yeah, that wild duck cluster M11 is an easy binocular object.
Yeah.
In fact, I think the first time I saw it, I was just scanning and I saw this fuzzy thing. What is that? And, pulled out my atlas and started to look. Oh, yeah, that's M11. So it's definitely an easy object in binoculars.
Nice. All right, so that actually concludes the Star Tour part. But before you go, we're actually going to take some questions and answer them right now. But before you go, if you enjoyed tonight's presentation, please drop a note to Kent. I actually copy and paste this entire thing and send it over to him. Let him know exactly what you liked tonight, what you're excited about, something that really made you go, ooh, wow, that's cool. I'm going to go look at that. And just let him know how you enjoyed tonight's presentation. That would be fantastic. So go ahead and drop that in the comment box, the chat box right now. You can also send me an email, questions@centralcoastastronomy.org, and let us know your specific questions and also your feedback from tonight. And if you aren't a member of our club, it's easy to become a member. You can just go to our website, www.centralcoastastronomy.org. That's super simple. And you can click on becoming a member, and it's super inexpensive, and you get to do fun things like this as well as the member hangouts. Okay, other question. We've got a number of questions. Brian, are you still? Kent, don't go anywhere. You're not done yet.
Yeah, I'm still here. So.
Okay, good. Brian, let me see if I can find you. Are you still here? Yes, you are.
I'm here.
You're hidden underneath all my windows. Hang on. Okay, hang on just a second. Gotcha. All right, Brian. So.
Yes.
All right. Do you have some questions for Kent? Do you want to?
Yes, I do. So this is a question from Louise. How do we estimate the distance when observing other galaxies?
There's the old redshift phenomena, and basically they started with the nearest galaxies trying to work out the distance, like Andromeda's the nearest big galaxy to them. They found these variable stars called Cepheids, and that was kind of like the first step to getting the distance to Andromeda. But for further away stars, or not stars, but actually further away galaxies, they found out that the further away it was, the more it was redshifted, which is actually, when you look at the spectra, it actually shifts more to the red end, which means it's moving away from us. And so they've been using redshift as kind of a really easy way of roughly finding out how far away the further galaxies are. For the closer in ones, and especially since we got the Hubble, they're using Cepheid variables. They basically, as a pulsate, the pulsation rate is tied to the absolute brightness, and so that gives you a standard candle. And so if it looks at a certain magnitude in this way off galaxy, you can work it back and say, oh yeah, that's 200 million light years away. But if you didn't have the Hubble, you'd be out of luck because you can't see Cepheids that far away easily. And so that's my quick and dirty explanation.
All right, excellent. All right, thank you for that one. Shall I go on with some more questions, Aurora?
Do you have a couple more questions?
Okay.
Anything?
I do.
Yeah, go for it.
Okay, so this is another question that came in. When you're looking up at the night sky, how can you tell the difference, if you can, between a planet and a star?
Planets, if you're just looking with your eye, you have to be patient. If you've never seen the night sky, planets move with respect to the fixed stars. In fact, planet from Greek means wanderer. They were the stars that moved across the sky, where the constellations of fixed stars, they always stayed in the same pattern for the most part. So if you didn't have a telescope, you're just relying on your naked eye. If you went out and looked at this star night to night to night, and it moved with respect to the other stars, you most likely got a planet. Also, it'd be relatively bright in comparison to a lot of the stars.
Now, I know also that stars twinkle. Is there any difference with that with the planet?
You know, it has to do with brightness. Planets, you know, the light coming from the planet still has to go through our atmosphere, and they can twinkle really good when they're low. When they get up, it just has to do with the brightness. Planets are usually pretty darn bright, so they don't appear to twinkle as much, but they do twinkle. So I've heard that, you know, that said about stars twinkle and planets stay steady. But in reality, planets are so bright they look steady, and you know, stars are usually relatively fainter, so it's easier to see something faint twinkling. And then also where you look at it. If it's straight overhead, it's not going to twinkle very much. If it's low to the horizon, since you're looking through all that wiggly atmosphere, you know, they can get almost anything to twinkle if it's down low. Does that kind of make sense, Brian?
Oh, yeah, it does. Yes, and I found that to be a fairly good gauge of the quality of the seeing. If planets are twinkling too, we know things are not doing too well with the atmosphere.
Oh, yeah, we usually have to sit back and wait. Wait for a couple hours and let it get higher, and then, you know, it's a little bit better.
Yes. I believe, too, in a sense, stars are a point source for us, and planets, because they're so much closer, have slight amount of angular size, and I think that helps have an object come through the atmosphere so there can be less twinkle when it's a planet.
That could be a point. Yeah, I'm not familiar with that, but you're right about it being from an actual angular source, and so that could definitely make a difference.
Very cool. All right. Well, thank you, Kent.
Nice.
And Aurora, I'm going to give this one to you.
Yes, I get the fun one.
Yes, you do.
We've had this one submitted quite a bit. So the question is,
Yes.
What is a black hole? So here we go. Really quick, and Kent, I know you're going to give me a really serious definition, so this is for the kids. So it's black because nothing can, once light goes in, it's not coming back out. And hole because once you fall in, you're not coming out the same way. And you can think of a black hole as, well, if I have this ball and I throw it up in the air, eventually it'll come back down, right? And no matter how far, now watch me like smack myself. And so what goes up comes down. What goes up comes down. If I were to throw this thing over 7 miles a second, now it's going at a speed that will escape the pull of gravity due to the Earth. If I were to stand on something more massive, like the sun, without burning up or getting squished, and I were to throw this, I would have to throw it a lot faster, like 400 miles per second before it'll actually escape the sun's gravitational pull. So a black hole is an object where that velocity that you have to throw this ball in order for it to escape that gravitational pull on it is faster than the speed of light. So a black hole is an object where the escape velocity is faster than c, the speed of light. So you can think of it that way. So that's my quick and easy definition of how to think of a black hole. A lot of people think of them as giant vacuum cleaners, cosmic vacuum cleaners with infinite sized bags that go around and suck things up, galaxies and stuff. And really, they're really passive. They just kind of sit there and wait for stuff to fall in. They're not actively seeking their prey like a tiger. It's like a basketball hoop. It just sits there waiting for the ball to come in, right? The basketball hoop doesn't go like chasing you all over the court, right? So it's waiting for stuff to fall in. When it's falling in, it's actively feeding, and then you've got X-rays you can look for and all kinds of stuff. So in general, they're not something you don't have to worry about it. There's none nearby that we know of. There's actually, on the NASA website, you can look at the 20 plus, I forget exactly the number, of confirmed black holes we have in our area of the galaxy, which is kind of cool. And they estimate there's a lot more. They're just hard to detect. Kent, do you want to add anything to that?
I've got a nickel to throw in.
Absolutely. Go for it.
Yeah, black holes are really, really small also. If you're at a distance, reasonable distance, you can't tell the difference from the gravitational influence from a star. It's when you get in close, because it's like taking a mass the size of our sun and squishing it way down to something really small, probably about a couple miles across. Mm-hmm. So you really don't get in trouble unless you get close. And then there's tidal force problems and other things like that hit. But they are very small objects. You don't get big ones until you start talking about the black holes at centers of galaxies that have, millions of solar masses.
Yes. Yeah, it's like imagining Manhattan and you shove it into something the size of a shoebox. So even though it's the same amount of mass, but now it's so small and densely packed in there. And that's what we're talking about with black holes. Okay, cool. Thank you. Brian, you got any more questions for us?
That does it for the questions right now, I would say.
Awesome. I have a couple that have come in. Let me see. Kent, one of the questions is, what do you recommend for stargazing if you are a parent and you have a kid? Do we get them a telescope?
Actually, I get them a pair of binoculars first.
Okay, tell me about that. I'm holding a pair of 10x50s.
Yeah, binoculars are, they're cheap. They give you a view through both eyes, so you have a very wide field, so you can look around. They're real easy to learn the constellations with, especially if you're in a light-polluted area. And you can use them for all sorts of other stuff, like looking at birds or, faraway objects, or my girlfriend, use them to look at the neighbors or whatever, And so binoculars are really good. Because if you don't, the kid's not interested in astronomy, you can always use it for all sorts of other stuff.
Mm-hmm. Awesome. Another question that came in, can we see everything you just showed us tonight with binoculars?
No.
Most of it.
You can see most of the stuff with binoculars that we brought up tonight.
Yes.
You'd have to, for the ring nebula, you'd probably have to pop a filter in to actually pull that in.
Okay.
But otherwise, most of the stuff we've talked about tonight, you have to have a dark sky, and it's well positioned now. These objects are straight overhead, so you're not looking through that much atmosphere. So you could basically see most everything with binoculars.
Mm-hmm. Yeah, and honestly, telescopes are pretty useless if you don't know where to point them. And so learning the night sky, just by doing things we're doing tonight, we only stayed in a very small area, but we got to know it really well. And so you don't have to take in the whole enchilada at once. Just get to know one part of the sky, get to know the patterns, just practice seeing things over and over. That's why we repeated it tonight. And then move on to the next set of constellations, 2 or 3 constellations, and work on those. And then after a while, work on those. And pretty soon, as you work slowly at this, it's like working out at the gym. You don't just go once and that's it. You have to slowly work at it as you go along, and pretty soon you're going to be able to look out, and no matter what time of year it is, and go out there and be able to say, oh, you know what, I remember ABC is over here. And so it's a process of learning and discovery. Other questions? I do have one more, unless Brian, you've got one.
Yes, let me pass this one on that just came in. And I'd actually like to answer a little bit of it, because the question was asked, what is the best magnification for binoculars to use for astronomy? And I was going to propose that a 10 times magnification would be a good to start with. And as astronomers, the bigger the better, right? The more magnification we can have, the more light we can pull in, the happier we are. But there's always a trade-off. For instance, we have those binoculars behind you that require a tripod to hold them up. So the bigger we get, the heavier they get. And that's really true for any astronomical equipment. So 20, I would say, right? 20 by 70s or so. What are those?
Oh, those are 25 by 100.
Yeah, so that's 25 magnification with 100 millimeter opening or aperture, right?
Yeah, right in here.
So, and those will give you amazing views, but you're going to need a tripod, and then it takes a little more practice to get them pointed and aligned. So we say, like Kent, I agree with Kent and Aurora, start with a small pair and then grow from there.
Yeah,
Yes.
You're exactly right, Brian. My grandfather's naval 7 by 50s, I had to build up the strength of my arms to hold them.
Nice. Okay, let's see.
So I have another question that came in,
please,
if you'd
go ahead.
like. Sure. So Mohammed had just asked, what kind of telescope do you recommend, reflector or refractor? And so
Well,
Kent, I'll go ahead and pass
basically,
that to you.
larger's better. So refractors are more expensive than reflectors.
Right. And
And-
so oh, go ahead, Kent.
Oh yeah, so basically, if you're, as a really nice telescope, those, what are they? About 8-inch Dobsonian mounted reflector. I don't know who's selling them. Orion used to sell them. They were relatively cheap. Where I don't even know what the price of an 8-inch refractor would be. It'd be way up there.
I see, for the most part, with the refractor, which, by the way, for those listening, would be a series of lenses all in a row, refracting or bending the light to magnify it. We usually see about 5 inches to be about the max for practical, although you look at those historical refractors, right, Kent, and they were quite large.
Oh, yeah, the one up at Lick Observatory is, I think it was a 36-inch.
Yes.
They actually had to modify the shape for the sag by its own weight. It was a work of art, but I believe it was the largest refractor in the world when they first put it up on Mount Hamilton in 1888 or somewhere around there.
Wow. Very cool. Yeah, and so for reflector, you get much more bang for your buck. And what I always like to recommend is, as soon as we can be all gathering in the same place, find your local astronomical club, and hopefully it's us if you're in the Central California area. Go out and try some telescopes that the club members have, and that gives you the best feel for what's available in different sizes.
Yeah, that's really good advice, Brian.
That's
Awesome.
awesome.
Thanks.
Okay, well, I think we probably need to wrap it up here. What do you think?
Yes, we are here at an hour and a half.
Yes, we've maxed out our time. So, all right, Kent, well, thank you so much for taking the time to share your expertise and your passion with astronomy. If you guys enjoyed it, make sure you let Kent know by leaving him a comment in the box below, or you can send it in to questions@centralcoastastronomy.org. Our next presentations you can actually find on our website, www.centralcoastastronomy.org. We're planning a stargazing session for September as well. But for tonight, this presentation will last you for the next couple of weeks, if not month. So that summer triangle is going to be up for a long time. So make sure you download this if you haven't already. This is the handout that went with tonight's presentation. And I encourage you to go out tonight and not just practice yourself, but share it with others so we can keep this going and have that ripple effect and have people that may not even have been interested in astronomy suddenly go, oh, wow, really cool. What is that Cheerio looking thing in my scope vision? So just be excited to do astronomy and science and keep the passion for astronomy alive. So if you do have questions that didn't get answered, please let me know. Aurora at centralcoastastronomy.org. And you can always send me an email. And if you've got a quick question, you better type it in now and Brian can answer it, because this chat box is about to go away. So you want to make sure you get your questions entered in. So Brian, thank you so much for helping out tonight.
Thank you. Glad to be here.
Thank you. And thank you, Kent, for being here. Those of you who are wondering, why can I not see Kent? He is actually he's just on a regular old phone talking to us. So he didn't have any star charts out. He was just having a conversation with somebody on the phone. So thank you, Kent. You're amazing. You've been my mentor for 15 years now. So thank you. Thank you. And,
well, thank you very much, Aurora. You have a good one.
Thanks,
Guys, take care.
You too.
See you later.
See you later, Kent. Bye.
Okay,
All right, everyone.
bye.
Take care. Brian, I will see you next time.
Okay, see you next time. Thanks,
All right,
everybody.
bye-bye. Thank you, everyone. Good night.